In this video, we're going to be looking at the rules of differentiation. Actually, there's no rules of differentiation. There's only one rule of differentiation. And it says this, the rule says this. It says, if I have a function f of x, right? Let's say it's ax to the power n. The rule says if I want to derive, remember this means you are deriving, you always take the exponent and multiply with the number on front of the x, the coefficient of x. So you're going to say a times n, which is an, then you write this. The x you still keep because you're differentiating with respect to x. And then after you multiply these two and getting your answer, you always minus 1 on the exponent. So it's n minus 1 there. That is just the rule. And if you have 5 terms, you are just going to repeat this rule on each and every term. If you have 100 terms, you repeat it. So you just need to know this rule for differentiation. Remember on our previous video, I already showed you this, but they wanted us to actually use first principles there, right? And I said on the exam, they'll always tell you if they want you to use the first principles, which is a long method of solving or differentiating functions, right? Or curves. But if they don't say use first principles, you're always going to use this rule because it's way shorter than first principles. Okay. Before I go into the questions, I just want to discuss different notations, right, of differentiation. So if you see these notations, you'll know that you are basically seeing the same thing. Sharp. Remember, guys, this f of x is y. Generally, g of x, h of x, k of x, anything of x is just a representation of y, right? Perfect. So now I'm going to show you different forms of derivative. So all this means derive. So if you see y prime, you see this is the same as f of x prime. It just means the derivative of the curve, or of the function, right? Perfect. Then there are other forms that we can write this. We can say dy over dx. This means that we are looking for the derivative of y with respect to x. So what it simply means, it means that y is the subject of the formula. Y is the subject, and then x is your variable. It's your variable. Perfect. Or they can say d of f of x. Remember, this is just y over dx. Here they just mean that f of x is your subject of the formula and x is the variable, right? Perfect. And then sometimes you can say dx of f of x. You see, so we're looking for the derivative with respect to x. So this is your variable basically of f of x, right? Or you can just replace that with a y. So when you see 1, 2, 3, 4, 5, you are just basically seeing the same thing. It shouldn't confuse you. It just means the same thing. So now we're going to do many examples of differentiation using this simple rule here, so that you get used to it. And then, yeah, that will be it about our differentiation rule. Okay, so let's look at this activity here, right? Number 1. So I'm going to look for y prime. Remember, I said you take the exponent, you multiply with this. So 5 times 3 will give you 15. And then you write your x. And then 5 minus 1 will give you 4. You always minus 1 on the exponent. But remember, you multiply first, and then you minus y after. Okay, then that's your final answer. Let's do number 2. Number 2, we're going to do the same. We're looking for p prime, or the derivative of p. Sharp. So it's quarter times 2 is going to give you half, and then you're going to get q, because it's going to be 2 minus 1, which gives you q to the power 1. But we know in maths, we don't show 1 then. Sharp. So number 3. On number 3, we're looking for, okay, guys, if there's nothing, since we still are beginning, think of it as having x to the power 0 there, basically. Remember, x to the power 0 is the same as 1, so we didn't change the meaning. So you're going to have f prime of x. Remember, you take this, you times with that, which gives you 0. Then you're going to have x to the negative 1, because you're going to have 0 minus 1. But the final answer is 0, because anything multiplied by 0 is 0. So guys, in simple terms, this is the other rule I need you to know. The derivative of a constant, it's always 0. By constant, I mean the number without the letter x. You know that if you're deriving a constant, you get 0. Okay, then let's do number 4. On 4, I'm going to use a different notation. I'll just say dy dx. This means the derivative of y with respect to x. It just means the same thing as that. Remember, I discussed with you on the notation. So I'm going to say 12 times 3, which is 48, right? And then x squared. Then remember here you have x to the power 1, basically. So you're going to have 7 times 1, which is positive 7. Then you're going to have x to the power 0, right? Because basically here is going to be 1 minus 1. So this guy basically disappears because x to the power 0 is 1. Do you see it? So you don't need to show it. If you get x to the power 0, you must know that you do not need to write it down. Okay, perfect. Now let's do number 5. Okay, on 5, we're going to have 3 over 2 times 4, right? Times the exponent, which gives us 6. So, but okay, I'm going to write the m over dn. Do you see it? M is the subject of the formula, n is the variable. Do you get it? So this is the subject, that is the variable. I'm just teaching you different ways, right, of the formats. But you could have just said, if you didn't want to do this, you could have just said m prime equals to, is the same thing. I want you to get used to the formats. Okay, so 4 times 3 over 2 gives us 6. And then we're going to have n cubed because we always minus 1 on the exponent. And then I said the derivative of a constant. This is a constant. We're going to have minus 0 here, basically, which we do not write. You need to get used to that. When you're deriving a constant, you do not write the things, the value, because the derivative of a constant is 0. Okay, now let's differentiate these guys here. Let's differentiate these guys here. Okay. So here, ladies and gents, we have firstly need to simplify these expressions, because before you can differentiate, you need to be able to see how many terms you have, and each term must be separated by a plus or a minus sign, and you do not need brackets at all. Perfect. So here we firstly going to remove the brackets. So we know that, okay, g at t, it's 4. Then we're going to have t plus 1, another t plus 1, and then we have t minus 3, right? Because this square gave us these 2 brackets. Then you keep on simplifying. We haven't started differentiating. So it's still g at t. I can multiply, I can deal with them like this. These 2, and then those 2. Sharp. So I'm going to have 4t plus 4 in that bracket. And then here I'm going to have t squared. And then I'm going to have minus 3t plus t, which gives me minus 2t, then minus 3. Okay, sharp. And then this will give me 4t cubed minus 8t squared. Remember, multiplying everything by 4. Then minus 12t plus, now we use the 4 to multiply everything there. So it's plus 4t squared, right? Minus 8t minus 12. right? Which becomes 4t cubed plus 4t squared, and actually is going to be minus, ne? Because minus 8 and that, right? And then minus 20t minus 12. I was just adding like terms there, right? Then there, and then the minus 12 doesn't have a mate, right? Okay, now we have simplified the brackets, and each and every term is clearly separated by a plus and a minus sign. So we can now simply do what? We can now start differentiating. Ne? So remember, this has been G at T all along, right? G at T. You need to show that you haven't started differentiating. And then now on this step, we're going to differentiate now. So I'll say G prime T, right? Remember, this times that gives you 12, and then you write your T, and then that is squared, right? This times that gives you -8, and then there you're left with T because you're going to minus 1 there. Then this times 1, it's minus 20. Remember, it's going to be T to the power 0. You do not write, right? And also, this guy here is a constant. I said the derivative of a constant is 0, so you don't write it. And then that is your answer for the derivative, basically. I'm hoping that makes sense. Now let's look at number 2. Okay, now we need to simplify K at T. Ne? I'm seeing I'm going to have 3 brackets there because of a cube. T plus 2 and another T plus 2. Right. All over square root of T. Right. Before I FOIL, I just want to discuss the root. Ne? So an nth root of A, right, to the power m is basically the same as A to the power m divided by n. This is very important. Ne? You need to know. Let me give you examples of what I mean there. If you have a square root of x cubed, right? Remember square root, there's a hidden 2 here that we never show. Ne? So this can be written as x to the power 3 over 2. So whatever was inside becomes at the top, whatever was outside becomes at the bottom. Let's do another example. Let's say I have a cubed, now I have x squared. This can be written as x to the power 2 over 3. You need to know this to convert from a root to the exponent. A root is just an exponent expressed in another form. You need to know that. Okay. So since I have 3 brackets, I need to deal with 2 first, right? So I'm going to deal with this 2. So I'm going to have t squared plus this times that, and then this times that. The final answer will be 4t in the middle when you add like terms, then plus 4. Ne? And then we still have t plus 2 all over. I can say t to the power half. We agree? Okay, let's not change it for now. Let's not change it for now. We'll change it later on. So there I have still square root of t. Sharp. And then now let's keep on going. We're going to have t cubed. I'm multiplying everything by t plus, t cubed plus 2t squared, right? Plus 4t squared plus 8t plus 4t plus 8 all over square root of t. Then now let's add like terms. We have t cubed plus 6t squared, right? And then we have here, we have plus 12t because this and that, and then we have plus 8. Ne? Sharp. And then here now we can change this to t to the power of, remember, there's a 1 inside and then there's a 2 there. So it can be written as t to the power 1 over 2. Now, this, if you have one term at the bottom, right, you're going to use the laws of exponents. Ne? You're going to minus everything by this, basically. So what you do is this. Ne? You basically have t to the power 3, you do this, and then it's t to the power half there. You split them, né? So it's t, I mean 6t squared over t to the power half plus 12t over t to the power half, right? Plus 8 over t to the power half. Then let's see what does that give us, né? Always when you have one term at the bottom, you split it to all the terms at the top, né? Now remember, the loss of exponents says if I have the same basis, I have to subtract the exponents, right? So what is 3 minus 0.5 or half? So here I have t to the power 5 over 2 plus, let's see, what is here I'm going to have t squared minus, so it's 2 minus 0.5, which gives me 6 t to the power of 3 over 2 plus, we can see that they're going to have 12t to the power half, because it's 1 minus half is half, right? Here we're going to have plus 8. Since there's nothing here, you can simply assume that there's t to the power 0, which will give you 0 minus half, which is minus half, right? Perfect. And then now we can start differentiating. We can start differentiating now. This is our k of x. Now we're just simplifying k of x. Remember, you need all your terms to be separated like this, you see? Sharp. And then the letter t cannot be at the bottom. It has to always be at the top before you can differentiate. Ne? Sharp. So now we can do k prime t. Right, remember there's 1 here. So 1 times 5 over 2 will be 5 over 2t. Then let's see, 5 over 2 minus 1 gives us 3 over 2. Then now let's check this. It's going to be positive 6 times 3 over 2, which is the exponent. It gives us 9. And then we can see that, okay, here if we minus 1, we're left with a half, basically. So we have 9 to the power a half, right? And then here we have 12 multiplied by the exponent, which is a half. That gives us a 6. And then here we can see that we're going to have t to the power minus half, right? Because half minus 1 is minus half, right? And then here I'm having 8 multiplied by negative 1 over 2. That gives me negative 4. And then I can see that I'm going to have t to the power negative 3 over 2. Because negative half minus 1 is negative 3 over 2. And that's it about differentiation. There is no need to write your exponent as positive. We'll just going to always mark it like this. Ne? So it should be fine there. Okay. So now that we're done with that, let's dive into the next part of this amazing rule of differentiation, right? If you are finding the videos helpful, please don't forget to hit the subscription button, as this helps with adding value on our channel and helps our channel to be discoverable. So we need more students to be able to discover the channel. So the more you click the subscription and advise friends to subscribe, the more you add in value. And thank you so much for that. Okay. So now let's look at this ones. Ne? So here, ladies and gentlemen, I need you to pause the video and attempt all these questions. And then we're going to discuss them just now. Okay. Okay. Now that we have attempted, let's go. So on A, you are looking for y prime, and your answer will be 6x. I'm sure you can see how I got that. 3 times 2 is 6. 2 minus 1 is 1. To B. So on B, you're going to have f prime x is going to be 25. Ne? Because 25, remember there's an invisible 1 there. So that times that is 25, then you're going to get x to the power 0, which disappears, right? Okay, now I'm looking for k prime x, which will be 0. Remember, I said the derivative of a constant is 0. So D, we're going to have y prime being equals to negative 4 times 5, which gives us negative 20. Then we're going to have x to the power 4 because that minus 1 is 4. This is a constant, it disappears. So it means we're done with D. Let's do E now. We're looking for g prime of x, which gives us 16 times negative 2 is negative 32. Then we're going to have x to the power negative 3 because negative 2 minus 1 is negative 3. And then on F, I'm looking for y prime. Ne? And then guys, on F, I can already see that there's no x. That means this, even if I FOIL and do everything, is just going to be a constant. So y prime is 0. Right, the derivative of a constant is 0. Ne? Let's do G. On G, we're looking for Q prime x, which is 4x cubed, because there's a 1 here. So 4 times 1, it's 4, and then you minus 1 there. This is going to be 12x. Then the derivative of a constant is 0. Right. Perfect. Now we're going to go to H. I'm going to go to H now. So on H, right? On H, let's see. We're looking for dy over dx. I'm just using a different notation. It's going to be 2x plus 1. Because this is 1. So 1 times 2 is 2. And then 2 minus 1, it's 1. Then here you have 1. 1 times 1 is 1. Then you're going to have x to the power 0 there, which disappears. Then the derivative of a constant disappears. Sharp. I am going to use the different notation. I'm looking for dx of f of x. Right. Which means I'm basically going to have 1 over 3 times 3, which is 1. So I just have x squared there because 3 minus 1 is 2. Then I'm going to have minus 2x. Right. This guy will disappear since it's a constant. Then here you're left with x to the power 1. Right. Sharp. Now let's do J. I'm looking for dy over dx, which is basically going to be 9 over 2, because 3 times 3 over 2 is 9 over 2. Then I'm going to have x to the power half, because I'm taking away 1 there. Then I'm going to have minus 4, because 1 times minus 4 is minus 4. And then here I'm going to be left with x to the power 0 when I take away 1. And then the derivative of a constant is 0, right? Perfect. Now let's do K. On K, we have g of x equals to x plus 2 plus 5x. Remember, I said we don't need brackets, ne? So I need to remove the brackets first. So I'm going to have x squared plus 2x plus 5x, right? Remember, this times that, and then that times that. Then I'm going to have x squared plus 7x, ne? Perfect. And then now, remember here I was not yet differentiating. I was just simplifying, getting things ready. Now I can differentiate. So I'm looking for g prime of x, which equals to 2x plus 7. I'm sure you understood how I got that, ladies and gents. Now I'm going to erase quickly so that we can do the remaining, right? So let's do I now. Let's do I. No, I mean L, ne? We're doing L now. So on L, we just literally need to multiply everything by 200 first, because we don't need the bracket. So we're going to have 200x cubed. Then we're going to have minus 100x squared. And then plus, what is 200 multiplied by 1 over 5? I think it's 40x, ne? Then minus, what is 200 times negative 40? Give us negative 8,000. Ne? Perfect. So now we remove the bracket, we can get the derivative. So 200 times 3 is 600, then x squared. 100 times 2 is negative 200, then x, because we take away 1. Here is going to just be 40, because 1 times 40 is 40, and then this will disappear because it becomes x to the power 0. This guy also disappears because the derivative of a constant is 0, right? Okay, perfect. So now let's do m. We have y equals to 14, x minus 1, then you have half plus x squared. Ne? Sharp. I'm going to firstly multiply 14 into the first bracket. So I have 14, x minus 14. Then this gives us half plus x squared. Remember, we need to remove the brackets first before we can differentiate. So now here I'm going to have 14 multiplying this and that. Half times 14x gives us 7x, right? And then 14x times that gives us 14x cubed. Then we're going to do the same with this one. This times that gives us minus 7. Then this times that gives us minus 14x squared. Now we remove the bracket and everything looks good. So we can do y prime, right? So here it's 1. So it's going to be 7. X to the power 0 will disappear. Plus, what is 14 times 3? That is 42. So we get 42, and then we minus 1 there. So take away 1, we get that. Derivative of a constant is 0. Negative 14 times that is negative 28. And then x, because we have 2, take away 1, right? And then that's it with m. Let's keep on going. Keep on going. Let's keep on going. Perfect. So we have 2 here. I advise you to still pause the video again and try on your own. And then we're going to discuss. Ne? We're going to discuss this together. Sharp. So on number 2, we can see that, okay, we are given f of x equals to this, and then they want us to get the derivative of f of x, right? Remember, I said no brackets, no fractions, right? Your x cannot be at the bottom. Ne? X must always be on top. So sorry about that. So we need to remove the bottom. Ne? So I'm like, okay, f of x, right, is this. I have a trinomial here that I can factorize. And then remember, as I gave you tips, I said my experience is one of the factors will be the same as the bottom. So I already know that, okay, one of the factors will be x minus 2. Because I need to have x squared here, I'm going to have x here. So that this times that will give me the x squared. Here I need to have positive 6. So in here I must have negative 3, right? So that negative 2 times negative 3 will give me the positive 6. Then you can see that, okay, this gives you minus 2x minus 3x, which gives you minus 5x. So you know you factorized properly. But yeah, always one of the terms will be the same as at the bottom. Ne? Now your f of x is basically x minus 3. Now you can easily differentiate that. So f prime, remember here you have 1, you have 1. So 1 times 1, it's 1. Then the x will disappear because you're going to have x to the power 0. This will also disappear because the derivative of a constant is what? Is 0. Perfect. Now let's do 3. On 3, we can see that, okay, we have f at y equals to square root of y. Remember I said if there's nothing, it means there's a 2 and then to the power 1, right? Then I showed you that this can be written as 1 to the power half. The inside exponent always at the top, the outside at the bottom. Sharp. Then now we can do f prime y, right? Prime y, remember there's a 1 here. 1 times half, it's half, ne? To the power negative half, because it's going to be half minus 1. And that's it about number 3. Now we're gonna go to number 4. Let me quickly erase. So now let's get to number 4, ladies and gentlemen. So on number 4, right, we have f at z is equals to z minus 1, z plus 1, right? And then remember I said no brackets, so you need to FOIL first, ne? Or to multiply. So this times that, then this times that. I'm not gonna times this and that and that and that, because this is the difference of two squares. But if you want, you can do it in the long way, but the middle is either way going to cancel. So either way, you're going to just be left with z squared minus 1. Ne? Therefore, we can do f prime z now. F prime z, which is going to be 2z. Because there's a 1 here, 1 times 2 is 2, and then z. The derivative of a constant is 0. Perfect. Now we can go to 5, right? So on 5, you have y equals to x cubed over 2. I'm sure you can see that this we can write it as x to the power half, right? This guy here, né? And then minus 3 over x. And I'm sure you still remember I said if you have one term at the bottom, you're going to distribute. Né? Here I couldn't distribute because I had 2 terms, but here I have 1 term, so I'm going to easily distribute. Né? Sharp. So it's going to be x cubed over x to the power, I'll just show 1 there. Then it's minus 2x to the power half over x to the power 1 minus 3. I can put x to the power 0 there to make things easier. Then here I'm going to have x to the power 1, right? Therefore, you can see that your y is going to be, here you subtract, you get x squared. And then you have minus 2x, let's see, it's half minus 1, it's minus half. Then there you're going to have minus 3x to the power negative 1, because 0 minus 1 is negative 1. You see, now we can do y prime. So y prime is going to be 2x plus 1, because negative 2 times negative half is positive 1. And then minus half minus 1, it's minus 3 over 2. Then negative 3 times negative 1 is positive 3x to the negative 2. And we have differentiated that guy now. Okay, that was number 5. Let's now go to number 6. Okay, I'll quickly erase, ladies and gents. So we're going to do 6 and 7 quickly. 6 and 7 quickly. Okay, let's go to 6. So on 6, we have y equals to, remember there's a hidden 2 here. So you can easily see that can be written as x to the power 3 over 2, as I said earlier. Then here is like you have x to the power 0, né? So you have plus 1 over 3, x to the power negative 3, because it's going to be 0 minus the 3. Okay, now we can easily do dy over dx, which is basically 3 over 2, because it's 1 times 3 over 2. And then on x, we're going to have a half now, because we took away 1. This times that gives you negative 1. Then we're going to have x to the power negative 4, because minus 3 take away 1, it's minus 4. And that is our final answer. Okay, now let's check 7. So this was 6. So on 7, okay, 7 looks too long. I'm going to quickly write it here. I have dx equals to x to the power 3 over 2. Okay, let me reduce the size of the pen actually. Let's make it to 4. Let's see how it's going to, or 3 is fine. X to the power 3 over 2 minus, you can see that here is going to be 3x to the power negative half, basically. So I just took this, I acted as if there's an x to the power 0 there. So 0 minus half, it's minus half. And then because there's a square, I'm going to repeat this twice. Ne? So x to the power 3 over 2, because of that square, minus 3x to the power negative half. Right. And then this is still dx. We haven't differentiated. We're still simplifying. So this times that gives us x. Remember, you add the exponent. What is 3 over 2? 3 over 2 plus 3 over 2. That gives us 3. Ne? Sharp. Then this times that is going to be negative 3x. So it's going to be 3 over 2 minus half, which gives us 1. Right. Which gives us 1. Let me just confirm. Yes, that gives us 1. So here you have x to the power 1. And then you do the same with this and that, this and that. So when I have negative 3, x to the power 1, because it's going to be 3 over 2 minus half. Do you see? Then this one and that one will give us positive 9, because negative 3 and negative 3. Then we're going to have x to the power negative 1. Ne? Sharp. And then now we can differentiate, because we no longer have a bracket. Ne? This notation just means that, okay, so this is our function now. We differentiate. So when you differentiate, this guy will disappear. So you are going to have 3x squared minus 3 minus 3 minus 9x to the negative 2. We can see that we have like terms here. So we have 3x squared minus 6 minus 9x to the power negative 2. And that was number 7. Now let's do number 8 here. So number 8, they want us to get dy over dx. If x is that. Ne? So here they are trying to trick us basically. Remember, the y must be the subject of the formula. So we're firstly going to make y the subject of the formula. So we're going to have, okay, we have, I'm going to flip. Ne? I take the 2y this side, and then I take the x that side. And then the plus 3 still remains this side. So this goes there, that comes in. So the signs changes. Then I'm going to divide everything by negative 2. Right? So y equals to half of x plus 3 over 2. Right. Perfect. Okay, now that we wrote y as the subject of the formula as they want us to there, we can now get d of this y, which is the derivative of y, with respect to x, right? So remember, here is 1. So this times that will be half. And then you're going to have x to the power 0, which just disappears. And then here you have a constant, the derivative of a constant disappears. Ne? I'm going to cancel 10 out because you already did a question exactly the same as this. If you go back, that was k of x. Ne? They just replace the x with, the k with p of x now, or p of t, but it's the exact same thing. So the last question that we're going to do is question 9. Ne? Okay. Perfect. So let's do question 9 as our very last question on this video. And then I'm going to keep on making more and more fire content, né? To help you excel in this subject of mathematics. Okay, so this one, right? We need to simplify. Remember, I said no bracket, so f of theta equals to 2. I'm going to make 2 brackets because of a square. So it's going to be theta. And then you have to the power 3 over 2 minus 3 theta to the power negative half. Ne? Then the same thing in the next bracket because of the square. So to the power 3 over 2. Then minus 3 theta to the power negative half. Okay. So now we have f at theta, which is the same as 2. Now let's see. This times that will give us 3. So it's theta to the power 3, because 3 over 2 plus 3 over 2 gives you 3. You add the exponents, remember. Then when I have minus 3 theta, 3 over 2 minus that gives you 1. So you have 3 theta, and then it's going to be minus another 3 theta. Ne? Going to be minus another 3 theta. I'm just realizing something. Number 9 and 7 are exactly the same as well. So minus 3 theta again, right? Just that they replace the x with a theta. Do you see it? So if I take this up, you're going to have a theta there. And they also put a 2 outside. Then I'm going to have plus 9 And then I'm going to have theta to the negative 1. And then now I can multiply everything by 2. Okay, let me show you something actually here. You can always differentiate. You see inside the bracket, you don't have any bracket now. Each term is separated. So I want to show you the other way. You could multiply the 2 in first and then differentiate after. But I'll show you another way I'm going to do it. Ne? I'm going to do it this way. So the derivative is going to be like that. So here there's 1. So it's going to be 3 theta squared. Remember, this is minus 6 theta. Ne? So it's just going to be minus 6 there. Because here we have minus 6 theta to the power 1. So this times that gives you minus 6. And then you're going to have theta to the power 0, which disappears. Then there you're going to have minus 9 theta to the negative 2. Then you can now multiply the 2 in. So it's going to be 6 theta squared minus 12 minus 18 theta to the negative 2. And that's the derivative. And the last question of this video. If you found it helpful, like always, share, comment, leave likes, and subscribe to the channel. Thank you very much, ladies and gentlemen.